beta, the same induction motor plus synchronous generator up till article 4.9, whatever we have done. Lecture number 3B and lecture number 4. Lecture 3B will be actually today uploaded. Actually, I have it already, but I don't upload it every time because when I see the views and all that stuff, then I upload it. And lecture number 4 most probably will be by tomorrow, I guess. On Monday, beta. The quiz is on Monday. You are not getting the join link. The lecture is there. Let me please send me your. Actually, I don't have your Mohammed Rahman. Otherwise, I could have sent you the join link. It will be both, beta, subjective and objective type both. And I will take this quiz percentage as approximately something near about 10 for the whole grade. So be prepared for it. I'm telling you, like 4 or 5 days early than this. So come prepared for this one. Okay, and okay, don't worry, I will share the. Yes, it will be numerical type, Shahid Iqbal, and date is on Monday. Timing is 10:15. I will make it available at 10:15. So everyone, please be at 10:15 on Monday. And again, it will be like 10 to 15 minutes quiz and and you have to upload it. Please, at that time, try not to have any excuses about the internet or something like that. This is very, very important. Hamza, please solve. Sorry. Actually, sorry. Yes, sorry. It will be then 11:30 or 11:45. Don't worry on that. Actually, I forgot that the class on Monday is at 11:30. Don't worry on that. Quiz on Monday at 11:30 approximate time. 11:30. We will start at 11:35 or 40 approximately. Maybe after the quiz we can have a small Viva session also, because by Monday I guess I will have started synchronous motor also. Synchronous motor is not that long. If you understand synchronous generator, synchronous motor is just like a piece of cake as far as the phasor diagrams are concerned. Overall, nothing much fancy about it. The synchronous generator is actually the main. Hamza bin Abdullah, but okay. Hamza, please talk to me about it in detail. What is actually the issue and what type of issue, so we can have arrange some Google form or something like that. Because in Google form it's relatively easy. The time is also checked in and all that stuff. But remember, time is very critical in that also. The time I can write the scripts over there for the Google, and then it can have all the. Okay, we can have some Google form or something like that maybe. So, but remember, it is again time critical. So anyone having internet issue or something, because today I had this class, so I always have my internet device always working. I have a backup battery also available and all that stuff, and in fact I am online from my mobile as well and from my laptop as well. So please have a backup with you every time whenever you are at some point in an exam or something like this. So you can't just rely on technology or something. I have not said, Mohammed Raviz, I have not said anything special up till now. I have just announced that there is going to be a quiz on Monday. The course is induction motor and synchronous generator up till article 4.9, and this will be on Monday at 11:30. The quiz will be of approximately 10 to 15 minutes, and you will get like 3 or 4 minutes to upload the answer sheet, and then certainly after that we will have a small Viva. of certainly some selected candidates, most probably from section C mostly, because last time we had section D as the main vital questions. And plus, I'm recording this also, so don't worry. This will be uploaded on the YouTube channel again. I want questions better. I need questions over here today, so I can know which questions are required. Okay. Any questions better? Any questions over here? You can ask me. Okay, Faisal Kawal, you have asked that in the short circuit ratio topic, they have written that this will be reciprocal of the per unit value of the reactance. Yes, it will be per unit value because if reactance XS is actually the important one. So if you read the definition of the short circuit ratio, in fact, let me share the screen as well, and then I can show you. Let me go in the Chapman. Any one of you having electric machines, the fundamental Stephen J. Chapman 5th edition, kindly please share with me. I have the 4th edition. It creates a lot of problem for me. There is not much difference, but there is a one chapter upside down difference. Chapter number 3 has been taken out actually from the 5th edition. Otherwise, it's the very same thing. Difference, but still. Okay, I can share the screen now, so everyone can have an idea what I am actually referring to. Okay, as you can see over here, it's the ratio of the field current required for the rated voltage at open circuit, which I have highlighted over here, to the field current required for the rated armature current at short circuit. So it's actually a ratio for the two values that you calculated in your previous page, which was actually this XS. You calculated XS equal to EA divided by IA over here. What was EA? EA was the value of the induced EMF inside it. It was actually EA or V phase because it was at no load. So IF at a rated value or at some designated value of IF, you got it over there. And then IA at again that same value of IF, so you got that IA as a short circuit current over there. That was calculated again over there. So XS was formulated over there. Now when you talk about the short circuit ratio, it is the ratio of the field current required for the rated voltage. Now this time you are not taking the EA, you are taking the field current required for the rated voltage at open circuit to the field current required for the rated armature current at short circuit. And it can be shown that this quantity is actually the same statement, reciprocal of the per unit value. Now whenever you want to find out the per unit value, what you do, you divide the actual reactance, which is XS, by what? You divide it by the main base value of the reactance of the machine over there, or actually Z over there. So when you are dividing it by that value, you are actually dividing this EA by the same value, or the graph which you have actually seen over there. This was EA and this was IF over there. So when you are dividing it over there, you are actually trying to make this this equation over here, you're trying to make it over here the field current, say, oh sorry, this one is the field current and this one is the field current corresponding to that. So when you are dividing this EA by the respective value, you are converting it into the same IF field current that is required over there. This one over there. So it can be shown that the quantity is just the reciprocal of the per unit value of the approximate saturated synchronous reactance calculated over here by that was equation 5.26, the same equation. So when you are dividing this by the per unit value, आपने per unit में इसको convert करना है, then you are actually going to have EA divided by the base value and similarly IA divided by the base value. So this is actually going to be going into the field current that are required for the two quantities over there. असल में मैं इसकी प्रूफ में नहीं जा रहा हूँ अभी, इसके एंड में एक प्रॉब्लम भी है at the end of this chapter, so I'm not going into the proof of it. You can do the proof yourself. Okay, just simple hint over here is this, that you have to divide it by the same over here. ठीक है. अगर ये ना हो किसी से तो please you can ask me in the chat window, no issues over here. But it's a little end problem as well, so and short question at the end of the chapter, so I'm not answering it deliberately over here. G, any questions else? But one thing very important, your final exam, whenever it's going to happen, I don't know the department has cleared it up till now or not, but whenever it's going to happen, it's going to take the whole course, the DC machines, the magnetic circuits, the transformers, and everything. So please do not just forget everything that has been done before. So the paper which is going to be long, the final paper, whenever it's going to happen. I just the date has been announced. Hamza, please verify on this one. Maybe the date has been announced. So whenever it's going to happen, so please do not forget it. This is very very important because the paper is going to be like I'm going to give like 6 or 7 hours, and the paper is going to be a long stuff. It's not. It's going to be like 3 hour paper something because it's going to be midterm plus final. So certainly, I am going to have an open book type paper, and certainly we will have a combined paper for all 4 sections in consultation with Sir Umar Latif. Hamza, even if you are speaking, I can't hear you because your mic is muted or something else. I can't hear you. One thing very important, those who have started synchronous generator, this these numericals where I'm scrolling at present, this example, it's actually example number 5.2. This is actually going to be 4.2 in your 5th edition. So this is 4.2, and this example very very important because here you are calculating the efficiency, you are also calculating the input power, and you are also calculating EA. Remember, this is the vector sum. As you can see over here, this is the vector sum of all the vectors. V phase is actually the reference vector, that's why it has an angle 0, and then you have RAIA. Now many students, whenever I have seen in the last few years, they do the mistake actually that they just take the magnitude values and they don't take the angle. So this is very very important that you take the angles also in accordance over here, that is minus angles or whatever the angles over there. So this is the lagging current over here. So this why you are having minus 36.87 over there, because this was actually supplied in the question statement over there. And I hope everyone has an idea how to actually use this open circuit tables from over here, that based on your field current what open circuit terminal voltage you can use over there. Secondly, very importantly, if you are asked, like supposedly in a question number 5.3, there is a lot of phasor diagrams involved over there. Please have a habit of actually drawing the phasor diagrams and then taking, like over here, supposedly if you can see this diagram, here IA is the lagging current by an angle 36.87, and then you have these two right angle triangles over here. So this is excess IA cos of theta, this is excess IA sin of theta. So when you are formulating the whole equation, you can see over here in this equation, V phase is the unknown. So when you are trying to find out this V phase, and then this is the triangle over here. So when you are doing this stuff over here, so this has to be very very carefully. So this diagrams are very important because you have to apply the Pythagoras theorem. So you require a lot from the diagram. So please have a habit of this diagram. That's why I have indicated that these questions 4.2, 4.3 and 4.4 certainly they are very very important from even the exam point of view. You can see the same equation is written over there. This is the same equation from the same phasor diagram. EA square, this is actually the hypotenuse, and this is the base value, this is the perpendicular over here. And when you want to rearrange it so that you can find out V phase, so this is actually that V phase minus this one. And then there is the MATLAB M file, which is not actually of our very concern, but overall this V phase value is very very important over here. So this is very important over here. Any questions, G, from the audience? Please ask me if there is any questions. Meanwhile, I will just take sure, because actually I've just seen that there is a problem at my D drive, or D drive I guess. Um, when iron is involved over there, so certainly this means that you are going to have saturation of that iron also taking place. I hope the sound does not fluctuate. I have my fan even closed at present, so my voice should be clear. I'm again answering this question that why the air gap line is straight. Air gap line is straight because the air gap does not saturate at low field currents or something. So you are not going to have any change in the air gap. The air gap is going to have no saturation. It has a slope equal to 4.10 raised to power minus 7, but because in that air gap there is also iron involved, because the flux is originating from the iron and then passing through the air gap and then inside the iron and then again completing the path of the same trajectory. So certainly this is going to be a straight line, but afterwards when the field currents increase, then certainly the iron which is in this path is going to saturate over here. Rujit Fan. Okay, Hamza and Tamur, please have a discussion with me on this one so that we can formulate some easy strategy on this one. Yes, I have heard from Hamza that there has been issues on turn-in. But actually, email is not a good option. Actually, 90 plus emails, and then I have to uh, download those emails, and it's a very difficult thing. So maybe some Google form or something like that is a feasible option. I will give that link, and it will automatically, so whatever time, it does not depend upon your system time or your entry time over there, but in Google form you have to be very very careful that the name of the file which you are going to send and the name which you are going to type is very critical. If you write down the name of any other person or something like that, you are finished then. So this is very very important. So that's why MS Teams option is good, because you are logged in from your own ID and all thing. So that cannot be done. So that's why actually I guess MS Teams is a preferable option for me. Uh, there have been I have seen the option of MS Teams has a little bit better option for the educational activity or something like this, exams or something. Zoom and Google Meet, they don't have any such options, I guess. Yes, Google Classrooms has a good idea. Yes, that can be done. Yes, Google Classroom is a good idea, but again, I will have to make IDs of every person and I will have to give a Google Classroom ID, because I have been using Google Classroom in the last year, if you remember, if you were doing electrical workshop with me. So Google Classes was the idea, I guess, at that time. But again, file name and all that stuff is a difficult thing. Any idea, Hamza and Tamur, why the number of students is less than even 50%? The number of students are just like 38 at present. Any particular reason of having less number? Now even 36, 37. Yes, Meera Zafar, question paper or the quiz will be subjective type and a little bit objective also. Uh, so because they might be heartbroken due to the quiz. I just announced the quiz. So I don't know which quiz, maybe some other subject quiz you are talking about. Oh, okay, signals. Don't even. Uh, maybe, I guess if I'm not wrong, Sir Asim Ron is the signals in charge. So most probably. Okay, ये मसला आ रहा होगा. Yes, I know, I know, I know. Yes. Maybe that. Maybe that comes. Salah Shafkat, I am on it. Beta Mirab, if you know the quiz, you can solve it. And if you don't know it, you cannot solve it. this is the philosophy behind this all the you can call it the online quizzes and online teaching. It's not something a 3 hour exam or a 4 hour exam जहाँ पे you have to use your brains over there. It's actually how much learning you have already got. ठीक है, वो आप फाइनल एग्जाम्स के अंदर आप कर सकते हो, जिसमें आपको हम एक पेपर देंगे and that paper is going to be open ended. Certainly you can open the book, you can open anything, because that is going to be an open exam. So in that case, yes, you can use your brains or something like that. But over here, for this like of a small quiz, subjective type or objective type, whatever, इसमें सोचने का टाइम आपके लिए नहीं होगा, ये इम्पॉसिबल है. मतलब आप, आई एम नॉट आस्क यूजिंग गोइंग टू यूज द वर्ड क्रैम ओवर हियर, बिकॉज माय क्विजेस आर नेवर क्रैमिंग ओवर हियर. Yes, even if it is a cramming, it is going to be some word, like just like I asked in the, I guess last week I asked it, that what was plugging. Those who have read the book, they knew. In fact, no one knew it at that time. So, if anyone has read the book, you will know what is plugging. Otherwise, if you have not read the book, you will have no idea that what I have asked over there. So, आप किसी को आप उस वक्त at that run time you cannot open the book and you can have like 40-45 pages scanned at that time. This is a very difficult thing. So बेटा ऑब्जेक्टिव टाइप रखने में कोई मसला नहीं है, बट इट्स इनी मिनी माइनम, इट्स लाइक दैट टाइप ऑफ क्वेश्चन. So I don't want to go in that stuff, because then luck plays its part. I don't want the luck to play its part. Yes, beta, numerical problem can be there. So please kindly go through them. I will try to. I've still not formulated any strategy on the quiz, because again, this is going to be a difficult thing. But most probably, there will be 2 questions. So I will try to take 1 question from synchronous generator, 1 question from induction motor. This is not a hard line strategy. Still, I still have to think on it, because I have to think those students, those who have studied. Uh, Please remember this thing. This is very important. I don't know, being as a student, how you think on this one, but since I have been a student at this university as well, and now I have been a teacher for the last 14-15 years, the purpose of the exam is actually to make a line between those students, those who are studying, and those who are not studying. It's not about the grade, it's not about something. When I was a student at that time, I had a discussion with one of my teachers at that time. He's not here in that university, he retired after that. I asked him, this is just a little talk I want to actually, because since you are students and you are always running behind the GPA and all that stuff, and you have never, uh, at my time, there was a 100 marks paper. There was no quizzes or nothing or midterm of that sort. It was a whole term something paper. It was a 3 hour paper of 100 marks. Now, the teacher philosophy behind was those 100 papers at that time was this, that out of those 100, there were like 5 or 6 questions. If there were 5 questions, he said 2 questions will be something like this of 20 marks each, that will be done by everyone. Okay? By everyone means those who have actually opened the book and they have done something. या at least 1 question ऐसा होगा जिसको सब लोग कर सकते हैं, जिसको शायद ये पता होगा कि मशीन्स में कौन कौन सी मशीन्स हमने पढ़ी हैं, वो ऐसा क्वेश्चन होगा. ठीक. सेकंड क्वेश्चन है वो ऐसा होगा जिसने एटलीस्ट कोई आखिरी 3 दिन में भी बैठ के या आखिरी 2 दिन में बैठ के मशीन्स को पढ़ लिया होगा. 40 मार्क्स हो गए आपको. तो आउट ऑफ दिस 40, इवन इफ यू हैव गेन्ड सम रॉन्ग सम राइट, एवरेज आपकी 30 भी आ गई है. After that 30, the next question, the next 2 questions वो होंगे, या next 1 question वो होगा जिसमें आपने जिसने क्लासेस ली होंगी वो उसको सॉल्व कर सकता है. और एक आखिरी जो 2 questions हैं वो ऐसे होंगे जिनको सिर्फ वो सॉल्व कर सकता है जिसने राइट फ्रॉम डे 1 अप टिल द एंड उस कोर्स को पूरी तरह से पढ़ा. सो बहुत अच्छी मार्किंग होती थी उस लिहाज से. वी न्यू एवरीवन कि जी पास हो रहा है, बिकॉज एट दैट टाइम पासिंग मार्क्स वर 50 एंड वी हैड टू सिक्योर दोज 50 मार्क्स. उससे कम इट वॉज अ फेल. आपकी तरह नहीं कि the average is coming out for the quizzes. I'm taking the word from Sir Asim Loans approximately, where the average is coming out 0 or 0.5 or something, and then he does the scaling out of it, and out of 100 the highest marks is 39. I have seen it. I have been, Sir Asim Loan has been the same tenure in this university like mine, so I have seen his averages and all that stuff. So this was the way at that time, and it should be a that's why I'm not a very big fan of this system, that is actually the GPS system and all this grading stuff, because grade is not good thing, because you're relatively scoring it. It should be absolute. It should be your fight with the book, that is Chapman. It should be the fight with the motor that you have actually studied. It should not be a fight with some XYZ person in your class or someone else. Okay. Maybe when you go in the industry, when you are fighting for a job, for an interview, then certainly you can fight over there, because there are 10 candidates over there and the company wants to hire the best one from there. Then it can be, but absolutely it should be with the book. So it should be an absolute. I'm not a very good vocal person for the GPS system and all that stuff over there. It has to be absolute over there. So please remember, whenever a paper is being made, the first most criteria is this, that you have to have a paper in which those who have studied, they can actually do that paper. ठीक है. एक क्वेश्चन कोई ऐसा जरूर होता है हमेशा पेपर के अंदर, जिसको जानबूझ के कोई टीचर, कोई भी टीचर, नॉट टॉकिंग अबाउट माई सेल्फ, कोई भी टीचर who actually wants to make it a little tough, a little difficult, so that उस पर थोड़ी सी brainstorming हो सके. And now this time, this is going to be the first time like this online teaching and all that stuff. So normally the paper is going to be open book, so it's going to be a little difficult on the side. So please, that's why, don't just cram the theory of the articles. Please go through the numericals, the solved examples, and the end problems. Okay, the paper is going to be mixed a little, maybe a little part from the synchronous generator coupled with an induction motor or something like that. So this is going to be something like this, at least for the final, not for the quiz. Maybe quiz is going to be very small time, so I'm not going to mix a lot over there. But there has been a question, sorry, I forgot it. Why the power factor of the wound rotor is low and for cage rotor is high? Better, very simple, because the wound rotor has a resistance involved over there, and it has to be externally short circuited over there, and you normally use a wound rotor for high starting torque. And if you have seen the torque curve, if I just go back over there, let me share my screen again. Okay, so if I show you the, so whenever you have a cage machine, and in that cage machine you have the torque slip curve. Just let me get to the torque slip curve of a squirrel, the slip ring machine. This is the normal curve for a squirrel cage machine. But when you are talking about something in which you are talking about a slip ring, which means R5 or R6 compared to R1, you are comparing these two machines. Now, if you compare R6 and R1, R6 is actually the slip ring, R1 is actually the cage machine. You can see for the supposedly 100 Newton meter torque, the speeds are different. And when speeds are different, certainly the losses over there which are happening inside the machines are different. So that's why the efficiency is also on the lower side, because you have taken the machine towards the starting more over there. And secondly, the resistance is increased over there. So certainly the power factor is going to be on the lower side for that machine over there. So the reason is very simple, that wound machine over there is going to have the low power factor as compared to the cage rotor over there, which is not high actually, uski bhi low hai. It has also having a low power factor, but overall the difference is actually going to be okay. 108, there is a suggestion from you to resolve the submission issues. There must be auto submission option. For this, you make use of creative or in the chat. Okay, please pass on this suggestion to Hamza. Hamza, please take this suggestion from 108. I guess if there is any link also related to this. But one thing very important, I don't know how many of you have the this app or something like that. Okay. So Hamza and Tamur, please have a discussion with yourself and see this operative and all that stuff, how this works and all that. But keep this option in mind, that all of the students have to have the harmony in the app over there, because I don't want it कि जी वो मुझे कह सकती मेरा mobile does not support that app or something like that over there, so it's going to be very difficult. So it's going to be very difficult in that sense. And whenever, I hope if you're going to take some pictures over there, if you're solving something over there, please take a picture of with the camera just parallel to your paper wherever you have placed it, and it should be covering the whole picture over there. And please use your flash or something, or if you are using the flash, I hope you have used some pointer or some other thing, no pencil over there, otherwise it's not going to be visible to me. So this is very important. uh, Any other question? Any other question regarding machines? Anything related to synchronous generator or synchronous or induction motor? So is this the only reason that we face decreases? So synchronous generator? No, 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 no. This is not the only reason. Because synchronous generator can work alone. It can work alone. Well, in fact, it can work alone if you have a constant speed. That's not an issue. Yes, we prefer that synchronous generator should be working in parallel with some other generators, so that if one fails, the other one is available over there, and you can increase the power from the second one. So in resistive and inductive loads, you have the V phase decreasing because the losses inside the machine is decreasing down. Okay, so synchronous generator, you cannot infer from this statement that synchronous generator should not work alone. No, 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 this is not the case. But if you take the UET case, we have three synchronous generators over there, 1.2 megawatts of each, and then there is a smaller one of zero point 0.6 megawatts, so this means 3.1 megawatts over there. We are working alone, those three generators. So this does this mean that we should not work then? No, we are handling those three synchronous generators in tandem, and when they were run at compressed natural gas, we were having a lot of uh, stable voltage over there. Okay, this is very important nowadays. At that time, the voltage was quite stable. In fact, when they shifted from that system of gas generators to the diesel generator, which is also placed over there, if you have seen it at the back of the main block, that diesel generator has a lot of fluctuation. In fact, I lost one of my laptops due to that fluctuations over there when they used to change the grid and all that. So the voltage was changing a lot, and because of that fluctuation, my laptop dimming IC actually got bad, and then it's unrepairable, or maybe I cannot find the IC. So there is no condition on this one. You cannot work it alone. If you have a very good prime mover, if you have a very good mechanical speed, then certainly there is no need of making the synchronous generator in parallel. If you can work at a constant speed, then certainly there is no issue. The only advantage of gaining them in parallel is this, that if one fails something, the other one can take up the work. मतलब आपके पास in Pakistan आपने अक्सर खबरें सुनी होंगी in the last, not in the last 2 years or 3 years, it has little improved over there, but 4 or 5 years back जी मंगला डैम के एक पावर हाउस के एक जनरेटर में आग लग गई. ठीक है, so does this mean कि पावर पूरे पाकिस्तान की बंद हो गई थी? नहीं. क्यों? Because they knew it when, as the instant the fire was on or whatever, the fire alarm triggered or whatever, the people over there, they used to shut it down, and they used to report this activity to NTDC, National Transmission and Dispatch Center in Islamabad, and based on that they used to ask the other people कि जी just increase the power from here. So one generator lost or two generators lost 100 megawatts of each, you can just increase the 200 megawatts. Now, at present time, I don't know how many of you still know it, that UET is, not UET, sorry, the Pakistan is actually having 3 or 4 dams at present, and those dams are very much on the charts. I don't know how many of you have seen this. I shared this 14th November, not 14th November, 14th July at 10:16 in the morning. And if you have seen this on the MS Teams, I uploaded this one at section C and D journal view. If you have seen this, there is a Terbela extension, there is Ghazi Brotha, and there is Mangala, there is Neelam Jhelum, there is Warsek. These are all hydel stations over there in Pakistan. And then you have the Jinnah hydel, then you have other, then you have Jamshoro, you have Kotri power, you have Lakra power. They are still at zero because they are not. Acha, interesting thing over here. Can anyone tell me if you see in the second column? I don't know how many have that list over there. I can share this one over here as well again if it's possible from my mobile. There are some stations such as Rausch and XCPC. They are at -1 megawatts. Okay. Can anyone tell me how a generator can work at -1 megawatts? Gee, anyone can answer this? Just write in the conversation window if it is possible. So please write down, then I will answer it. That if it is right or wrong, or then I can answer it also. The worst part, I'm just witnessing it. The total solar output of Pakistan at present is standing at 200 megawatts. It's very small. It should have been 1000 megawatts. Gee, anyone who can answer this? If you have seen the MS Teams, actually I can't share this at present. This is a little. They are taking power from the national grid power plant with negative sign. What does negative sign mean? Negative sign means that they have turned into a motor. Pradhan Arshad, please clarify. No, 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 no. It has nothing to do with Q negative beta. 102, it's not nothing to do with Q negative. This is P. This is just megawatts, not megawatts. आप कभी भी वापडा, you will never ever hear that वापडा is having or showing you that okay, we are producing this much kVAR or MVAR and we have load shedding of this kVAR. Nothing. They never post it out. It's only the megawatts always. Uh, then what it is? Tell me why it is negative. Why it is -1? Okay, here is a question. So tell about how the electricity is being transferred wirelessly because I have heard that some people sell electricity to Vodda. How it happened? You are mixing two questions, beta. Row number 4. You are mixing two questions at present. If you're talking about wirelessly, there are two techniques of doing this wirelessly. If you go to MIT website and you will see over there, the two methods are, one is by resonance, one is the oscillatory resonance, another one is the capacitive resonance over there. But I guess you have seen the wireless chargers and all that stuff coming in, but it involves resonance. And resonance, if it matches with the resonance of any other material in between, maybe if a person is standing in between and the body cells are going to actually resonate with it, it's going to be catastrophic. So wireless is at least not the need of the day at present. But if you're talking, because you have merged two questions, I don't know how you have merged these two questions. Yes, people are selling the electricity to Vavda, and how this happens, it's actually a 4-quadrant meter. Remember, it's a 4-quadrant meter, just like you have a Cartesian system of 4 voltage and current and all that. Here you have a Cartesian system of 4-coordinate system. You just open the first quadrant and the third quadrant over there. So if I'm not wrong, I just mean right, 1/3 over there. So you can only just take the power from the Vavda, or you can supply the power to the Vavda. Now when you supply the power to the Vavda, yes, I will come on because there have been some questions again more. Now, when you are supplying the power to Vavda, because you are only supplying it from maybe supposedly from solar or something like that. Actually, I have also applied for that license from Vavda. Vavda at present has approximately, I guess, 150 or 200 licenses given to private customers at present. Some factories, some residential customers. I have applied approximately for 6 kilowatt system at my home. I have a solar system over here, so I can supply an excess amount, maybe like 2 units or 3 units per hour to Vavda. And this means that, in fact, more than that, 2 or 3 units. If I am not at home, certainly in the morning, then I can supply back it over there. But the problem over here is that don't worry about Phazan Arshad. I am recording this, so I will upload it also. It must be something from your side. So the problem with this system of actually giving power back to Vavda is that Vavda only gives approximately 10 to 11 rupees per unit. And when you are taking the power same in the evening time, supposedly at 4 or 5 p.m. afterwards, the rate is approximately 19 or 20 plus times. So this is a very exorbitant rates over there, and they don't revise those rates. So it's not beneficial. Yes, certainly you don't need batteries to actually store it. You can just take it back. This is called as a grid tie inverters over there. Grid tie inverters, they actually work with the, but there's a problem with grid tie inverters, that if the grid offs itself, if the grid off, then certainly you cannot control, you cannot run your system. Supposedly you have a solar system at home, solar PV panels at home, and you have a grid tie inverter, and WAPDA turns off due to load shedding. Then you cannot even supply the power to your home even at that time, because you are in an island condition. This is called as island condition. And why this is called as an island condition? Because it takes that specific inverter, it takes the frequency from the WAPDA grid and produces the same frequency or the same shape at its inverter. And since it does not have any battery bank, it cannot generate it over there. Yes, research is still going on to actually make it something like this, so that at a on-grid inverter can actually start working in the same way. But it's still in the process at present. There are some solutions coming in now, but still it's not very good. अच्छा जी, no beta 109, it's not because of the negative voltage regulation. It's very simple. Whenever every power plant is made, there is always a colony involved inside it. There is always some people running, staying over there. So it takes that power as domestic utilization over there. Maybe the power plant has some lights or something. So if the plant is off for the generation, you still have the power being consumed over there because of some lights, some maintenance work going on, some administration building. And I guess every one of you knows it, that at Wabda, at Mangla and Tarbela, there is a big colony also involved over there. At Mangla, it's a whole city actually. At Tarbela, it's not a whole city actually. It's a little far away from it. But I don't know how many of you have gone to Tarbela or some place. But at Tarbela, just beside Tarbela, there is the Ghulam Isa Khan Institute, Sawabi, and just beside that lake, the Tarveda lake over there. So the power actually does not turn off at that point over there. There is no load shedding actually at that university even. The reason behind very simple, that they are connected with the Babda grid and they are connected with the Tarvela dam. So even if the whole country is off, then certainly yes, they will be off. But otherwise, there is no load shedding as such over there. So they are consuming the power, even if Tarbela is not working or Tarbela is off in some winter season, if the water is not available or something like that happens, then the power is actually flowing backwards over there. Acha ji, sir, Mohammad Rihan has asked us how, sir, Japan is controlling its power plant. Yes, beta, it's possible. Actually, there are some protocols over there. IoT is Internet of Things is good, but again, the backdrop of this is this, that you have to have the internet connectivity at its maximum. You should have a fiber optic connection, but the problem is this, that if you're controlling it wirelessly, you can be hacked. Okay? But if you are having a whole new SCADA system, the Pakistan is actually having a SCADA system. It's an old technique, but it has a SCADA system and it has power line carriers. Now, power line carriers is a totally new thing for you. On the same power lines, उन्हीं power lines के ऊपर जिनके ऊपर आपके पास बिजली जा रही है, the transmission lines, you send a signal of high frequency, because frequency जो उस पे जा रही है, that is 50 hertz. You can send a signal of 1 kilohertz or 2 kilohertz or 5 kilohertz signals on the same line, and since it's high frequency, it will travel from that power plant to the central location, maybe at Islamabad. So this can be called as a power line carrier PLC system, power line carrier system, PLCS over here. Now this power line carrier system is still not available in Pakistan in that fashion over here. SCADA system is totally different. It's a totally different network in which you have these network going on from Tarbela and Bangla towards, and it's being updated. The screen which I'm always sharing in front of you, actually some students at NTDC, they share that screen with me, or they are some of my friends from my batch, they share with me from NTDC. So that is actually updated after every 4 or 5 minutes from every power station. So at NTDC, they are actually controlling the whole power from there. Now, if you want to control it from IoT, you need some encryption. Okay? I am also sitting here over here. I am controlling a solar system which is placed at my parents' home at present, and here just sitting on my, even in fact sitting in the university, I can turn it off, on, or even have the battery voltage monitored. In fact, I can give the link over here. I have this. It's actually a little personal, but still anyway, I can share that link over here. This is the link over here I'm sharing in the chat window. So this is the link of my in the chat window I have just shared. This is the link of my website on which I am having monitoring the total 24 hours logging of my battery voltage at my parents' home. There's a 3.5 something 3.6 kilowatt actually power system, solar system over there, and it's running a single phase AC or something like that over there. Now I'm not giving you the controls of it. It's certainly authenticated over there, but even if I'm a university, I can control the power output over there. It can send me an SMS over there from, and I can control the whole power. It has all the recordings. You can go through the recordings and all that stuff over there. Yes, IoT is powerful in that sense that from anywhere in the world you can control it, but again it has to be encrypted. There has to be 128-bit, the maximum encryption available, so that it does not, because just imagine it out, your Tarbela and Magla falling in the hands of some foreign enemy, and they control it, they turn them off, or maybe through that channel, through going through the SCADA system and all that, they turn off all the power system in Pakistan, and then the army is left at the hands of the enemy. So this is very, very critical point. You cannot actually, so internet is never the something, and I have everyone over here know about the agencies working through the channels and all that stuff. So you have to keep such high-end uh, things away from the public domain. So this is very, very important that you have to make them secure. Okay. Even if they are doing it wirelessly or something, they will never give you the IP address or something like that. So this is very important. Any other questions, beta? If I have not answered anything, or uh, if I have missed something. Any questions from the audience? It's still 11. Okay, the attendees are now 66 over here. Still respectable, but still, I guess 28 or 27 students are 27, I guess, are not here. There should be 93, I guess, if I'm not wrong. Okay, there is one question. Example number 4.3, Chapman. Two values of WM are used. Why? Is it misprinting? Okay, let me go on. Example 4.3. Let me go on that. I'm sorry. Synchronous generators. We're asking for example number 4.3. It's actually 5.3 over here. Thanks, Hamza. You actually shared with me. I actually even downloaded it just now. You shared with me the issue number 5. I guess you gave me also before as well. I forgot it. Okay, this is 5.3. There are two values of omega m. Please, can you identify, beta, where are those two values of omega m? The speed, if you are talking in terms of the, this is the value of omega m, which I am selecting at present, and omega m. Any other value? Please write down in the conversation window, beta, which point you are referring to. Please verify. And there is one more question by Arsalan Khan. Please, beta, whoever asked this 109, please answer me on this. Which value you are referring to? Which two values you are asking? Because it's a 50 hertz machine, a 480 volts, 5 connected, 6 pole synchronous generator, per unit reactance is 1, sorry, per phase synchronous reactance is 1, and nothing else fancy. We just find out Nm, which actually translates to omega m of this. This is actually the synchronous generator speed for 50 hertz. So they have calculated it based on this one. So putting in F50, P number of poles 6, 1000, and then converting this 1000 into radians per second, because this is in revolutions per minute. Okay, part D you are referring to. Okay, just let me see. There is part D. This is B, and then let me C, and this is D. By using two different values, the induced counter torque is omega m and omega v. This is just, I guess, misprinting, because this omega m and this omega v, they must be same, because you're running the generator at one speed. It's not an induction machine where you are going to have two different speeds, from the synchronous motor point of view, the synchronous speed point of view, and the other one from the rotor point of view. So this is the same. I guess this is misprinting. Okay, in there is another question. In P in and P converted, used value is 120. Yes, I have just answered, I guess. Value calc. Acha, you are asking 125.7, and this is 125.7. Okay, and you are using, they have calculated it. Just confirm this out, maybe by using a calculator. This must be some error over here. Okay, यहाँ कोई error होगा. Just verify that this calculation gives you 100. It will give, I guess, 104.7. So they must have done some error over here, because 125.7 is nothing over here. So this is some error overall. So just verify the calculation, because it has to be same. Just verify it. Arsalan Khan was asking that, are there any drawbacks of sending electricity wirelessly? I guess the better person to answer this one would be Nikola Tesla, because he was actually the most vocal about getting power wirelessly. But since he's not here, but personally I feel anything that you send wirelessly will have some repercussions, and power of that levels will have a problem. I guess last lecture we were discussing this one, that the frequency used in Pakistan is 50 hertz, or in the West it's 60 hertz over there. Now, can 50 and 60 hertz are a little difficult for the human body if you get an electric shock. Why? Because the heart rate of a human normal person is approximately 65 to 80 or something, or normal range is 70 to something range. So it coincides with the frequency of the AC current. So you are actually asking the heart to actually have thrombosis, or maybe electrolysis taking place. So it has problems as such, as far as that is concerned. So when you are going to send wirelessly, that wirelessly is going to happen at kilohertz, or maybe megahertz. In fact, megahertz, not kilohertz, the megahertz over there. And at megahertz, the signal to noise ratio is going to be a very important thing. Secondly, still not confirmed from the masses, but personally I think that these cell phones, this wireless technology, this Wi-Fi, ABC, ABGN, or whatever AC that are being used at present, they all have some health hazards, but not that much. If you use it for prolonged time, yes, certainly they will have. So similarly, anything electricity wirelessly, sending them through the air, you will have a drawback. You will always have a drawback over there. But certainly, yes, everyone is not fond of wires, so you have, I guess, Salman Shahid, yes, it is possible. I guess there has been the experiment of Li-Fi. I guess just search on Google Li-Fi. Instead of Wi-Fi, they have searched on Li-Fi. On the visible spectrum of light in China, I guess they did this experiment, and this was reproduced in America as well. They did it, that Li-Fi, that based on Li-Fi, the visible light they used to charge devices, maybe mobile phones or something. So it's simple. You just turn on the turn on the light, incandescent bulb, and it's also producing that spectrum of that frequency in which it can charge that. But again, the problem is this, that the limitation is that if you will send high levels of power, those high level of powers are going to actually absorb in the human body or something, and it's going to. And I hope any one of you who is going to go in the telecom field and maybe after like 2 3 years, just come back and answer me this question, that if you see any of the persons who are climbing the BTS tower, certainly not engineers, the diploma holders or technicians who work over there, if by chance, because I have met some and I have seen some, if by chance they come in front of a microwave antenna, okay, the microwave antenna, that is actually the long shaped antenna that is just on the BTS tower covering the whole 360 degrees over there, if by chance you get an exposure of 5 minutes in front of it, 5 minutes exposure just in front of it, you will die in 2 years with a cancer. And there the power levels are very high. Okay, I'm talking about something in like kilowatts or maybe like 500 or 600 watts per the antenna over there. So if you are going to transfer powers at this level, maybe at that frequency again, because there are microwaves, they are working at some frequency over there. And if you are going to get a resonance or something like that, or capacitive resonance or something, that's why up till now you have not seen wireless charging taking place apart from mobiles. I guess there is a road also opened in Holland or in Europe. I don't know the exact location, where the cars can be actually wirelessly charged to the road. But what repercussions it would have, electric cars certainly. So what repercussions it would have on the occupants of the car, still not known. Because every time whenever there is a new technology, it's going to have its repercussions, and you are going to have problems associated with it. So you can't say that, I guess practically whoever does this wireless power and all that stuff by some other method, maybe not resonance and not capacitive resonance or the oscillatory resonance, but if it is done by some other means, maybe by laser or something like that, then certainly that person or that organization is going to be liable for a Nobel Prize also. So certainly yes. There have been 2 or 3 projects in the last 3 or 4 years at UIT Lahore. One of them was associated with me, two of them were associated, I guess 1 or 2 of them were associated with Sir Abdurrahman Kashif, and they tried to actually transmit the power from one point to another point. One was a total failure. The last one actually which then was like 2 years back. It was done, but again the power levels were very small. And our problem over here doing in Pakistan is that you don't have very high uh, frequency transistors or high frequency MOSFETs or GAN devices are not available. So this is a very big problem in Pakistan. You don't have access to such things. So you again have to reside on the West, and when you are residing on the West, they will not give you the best thing. This is very important. So even if you get the best thing, it is actually very, very low quality, and they must have done something better than that. So that's where one of the problems over there. And I guess one drawback, this is one question asked from me कि जी अगर मोहल्ले के, there's some questions asked me कि अगर वायरलेसली पावर आना शुरू हो जाए तो क्या पता चले मेरे घर में जो बिजली आनी थी वो किसी और के घर में चली गई है, और मेरे जो उसके घर में बिजली आनी थी वो मेरे घर में आ गई है. These are some lame questions or lame excuses, but still anyway, this cannot happen actually, but certainly because the power is actually the very same. But sending power wirelessly will have other problems as well, such as how you are going to meter it. It's going to be very difficult. Then you will ask for encryption of that power as well, कि जी आप उसका पहले एक रूट पासवर्ड आप उसका ब्लॉक करें, उसको encryption करें, फिर आप वो पावर ले सकते हैं. There are some options available, but again wireless power transfer is going to be just limited to a room. Maybe in room of like 10 meters or 20 meters you can do that, but not in the long run, not for transmission lines. Transmission lines बहुत मुश्किल है. It's very, very difficult. It's very difficult. आप कहेंगे कि तरबेला से लाहौर there's going to be a wireless line available. Maybe yes, you can send it into space and you can have a reflector in space and then you can return it back to Lahore. Yes, that is possible. That is a big idea. On this idea, some Russians have also been working. I read some paper some years back. Russians have been trying to work on this idea. So sending the power produced as microwaves outside and then returning it back to the space, it saves them the signal to noise ratio, because in air medium there are noises, there are other channels as well. other frequencies also available. So sending it in space, and then but having a reflector in space of that much dia and all that stuff is a very difficult task. Very difficult task. Any other questions? Any questions, Ji? Apart from this wireless power transfer, certainly. Any other questions related to synchronous generator or something? Actually, now last year also I wanted to have a trip to Nishat Power or Nishat Chunia. They are, I guess, something very close to Lahore, so we can visit them. But again, this time this is social distancing times and COVID times. We can't even visit them. So maybe somewhere in next year when you are actually studying power transmission and distribution, the CRs, I guess you both are here, Hamza and Jammu. Maybe if the times are good at that time, maybe next year, just arrange or just consult with me. Maybe we can have a combined trip over here, section C and not section C and D. Again, some selected candidates because they are a private entity and they won't allow a large number of students to go over there. But the better thing is that you can go to these plants when they are actually overhauling. The overhauling part is the most beautiful part because there the synchronous generator is open. Otherwise, if you go at the operation times, it's of no use. No use. Because you're just seeing a motor, a generator working over there, and you are hearing screaming sounds over there and all that stuff. So it's not the actual origin part for an engineer is it that you can see the actual rotor inside a synchronous generator. So maybe if you are having transmission or distribution course or something, PS power system, I guess that comes in 6th semester, I guess, if I'm not wrong. So maybe at that time you can visit Tarbela and Mangla. Frankly speaking, you won't find, yes, as far as the physical feat of having erected a dam and all that stuff, or that is going to be good to see. But overall, there are not much people over there unless and until you have some technical person to actually guide you over there. So seeing over there has nothing fancy about it unless and until you want to have a recreation trip towards the lake and all that stuff, or the beauty of the water and the mountains and all that stuff. Okay, looks like there is an issue with the internet. Okay, let me just verify it out. This issue is on my side or in its Teams. Okay, sorry, I'm again back over here. Ji, any questions? Ji, if anyone has still some questions over here. Yeah, any questions from the audience? I hope I am being heard on your side. Okay, the question is this, that instead of using a pilot exciter with a brushless exciter in a synchronous generator with large field current, why not use a pilot exciter with generator? Is brushless exciter used for emergency purposes only? Not emergency purposes. Actually, a brushless exciter is something where you don't have the audacity of having a permanent magnet over there. And a pilot exciter is something where you have like 3 stages over there, and then you can actually. The actual reason of using these two techniques is this, that you want the generator to be self-start. Okay, this is very important. But if you want to use those permanent magnets and all that stuff over there, a pilot exciter, this means actually that you don't, even if you don't have any power coming out from your in your powerhouse or generators, you can still on that generator. So this is very important from that point of view. so that you can start a generator. Otherwise हर generator house के बाहर आप अक्सर diesel generators backup बतौर जरूर देखोगे. Now, any of you, maybe supposingly, if you go to Mangla Dam, because Mangla Dam is a little old as compared to Tarbela, and if you go on the third deck of that powerhouse, you will find DC generators over there. Now, आप कहोगे जी कि वहाँ DC generators क्या कर रहे हैं? When the dam was erected, since the technology was old and whatever the stuff was there, so they used to take the water from there, run a small turbine over there, take some mechanical motion from over there, and used to produce DC current from there or DC voltage from there. And that DC voltage was actually fed into this actual synchronous generator from there. But nowadays they are just present over there. They have been cut off from the circuitry over there. Nowadays they have the diesel generators over there so that they can actually give power from there, because Mangla Dam generators, they are a little old, so you won't find a brushless, you will find a brushless exciter over there, but you won't find a pilot exciter on those schemes over there. They're a little old over there. Tarbela Dam is actually a little better, and I guess the last overhauling or last upgradation was done in, I guess, if I'm not wrong, 1990s era, and they actually installed an automatic generation system, AGS, over there. So after that upgradation, there is only a need of like 4 or 5 staff over there, and it's automatic. The NTDC people, they just have to, maybe the powerhouse is closed, everything is closed, it's locked, and it's being controlled remotely from the NTDC office. But yes, there are some persons always available over there at the site house, maybe at their homes or at the administration building, but not in the powerhouse, main powerhouse over there. So अगर आप वहाँ जाओगे तो वहाँ हू का आलम होता है, तो आप वहाँ देखोगे तो भाई आपको इस प्लांट चल कैसे रहा है. So it's a little difficult, and if they allow you to go in the main control room where actually they are controlling it and they are having person sitting over there, so it's a very fascinating control room. Maybe I can share some pictures of it as well. I went personally one time with some certainly some reference over there, and they allowed me to sit in that control room, and I saw all the buses and all that transmission lines originating from that point. And they have a big clock, certainly a very big digital screen, not screen actually, it's actually a digital meter over there just on the top of that wall, the main front wall, and on that wall, on the digital display, the frequency is displayed. And again, it's what is happening. The short circuiting currents, if they have to be avoided, you have to make into the frequency being controlled very minutely over there, and this can be only done by having the person sitting over there, and certainly something automatic over there. And one thing very important, I hope so, if anyone has gone through the lecture number 3A, you must have seen that whenever you want to increase the share of a generator with the power grid, you increase the governor set points, and when you increase the governor set point. Now, whenever a generator at Tarbela or Mangla or any other powerhouse, maybe if you want to increase it, there is not a person or an engineer sitting over there. They just give up the ramp up factor over there. They just feed in that ramp up factor, and that ramp up factor actually controls that, okay, after how much time they are going to allow that generator to actually increase its power share. It's not done instantly, like you got that 0 or something at 1 megawatt and you increase it to like 50 or 100 megawatts instantly. Not like this. It's a ramp up factor. It's certainly based on some factors over there, based on certainly the maintenance, based on the heating, and based on all other factors, and certainly the guide from the NTDC people that what amount of power they require over there. So they must have given some chart from the NTDC that how the power has to be increased at what time and all that stuff. So there is always some automatic system over there, and it's not just on the persons over there who can actually control it. Maybe they can control the shutdown and all that stuff, but they cannot control how the generator is going to increase its power from one point to the other over there. Do any other questions, or then I can actually, this is because this is just almost 11:23 almost. If anyone has any other question, you can ask me just now. जी बेटा 115 ये जो अभी ये हुआ है, ये 1 hour 9 or 10 minutes approximately on recorded on my side, excluding that part. I will just upload them. Actually the file actually becomes out approximately 400 to 600 GB or MB plus, and uploading it requires a lot of bandwidth. So अगर वो बीच में कहीं पे कोई maybe light goes on or something like that, so it's a little difficult for me. Anyway, again, it will be uploaded on the YouTube channel. Better no need to write down the roll numbers over there. I guess your name is recorded already in the Excel sheet I have. And please kindly, if you have not seen lecture number 3A, please kindly go through it, and lecture 3B hopefully will be uploaded by today evening, something at that time. So please kindly go through it so you can attempt the quiz on Monday. Okay, so I guess this is all for today because this is almost now 11:30, and just